So in this video, we are going over the 1.11 to 1.14 review. I'm starting with question number 15. So let h of x equal x minus 2 to the fifth minus x to the fifth divided by 3x to the fourth. Which of the following statements are true about the graph of, or which of the following statements about the graph of h is correct? So we're looking at horizontal asymptotes for these. Okay, so each one of these is talking about a horizontal asymptote. And so what we need to be able to determine is what the horizontal asymptote is. So that's when we're going to compare the degree of the top with the degree of the bottom. So we do need to somewhat expand this, and that would require us to do Pascal's triangle. So I have an exponent of 5, which means I need to go down until I get to row 5, or my second number is 5. So Pascal's triangle, we have 1, 1, 1. We have 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. So this is going to be the row that we want. So you don't actually have to expand the full thing, and I'm going to show you why. So right now, I'm only going to focus on the first two terms. So we have 1 and 5. So my first term is x. That's going to start with x to the fifth, and this is going to go to x to the fourth. My second term is going to be a -2. It gets nothing on the first one, and this is going to be -2 to the first power. So when this expands, this is going to be x to the fifth, and this is going to be a -10 x to the fourth. So when we look at this, we know that we have x to the fifth minus 10 x to the fourth plus dot, 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 and then a minus x to the fifth. Well, what happens is these x to the fifths cancel out, and so then my degree on top ends up being a degree of 4. My degree on bottom ends up being a degree of 4. So that tells me that my exponents are the same. So we're going to divide their coefficients. So we're going to take -10 and divide it by 3. That doesn't simplify, which gives us the answer choice of D. Looking at the next one, write the equation of the horizontal or slant asymptote for each of the following rational functions. So again, comparing the exponents. So we have here a degree of 2. Here we have a degree of 2. That is another case of exponents being the same. So we're going to divide their coefficients. So that means we're going to have, first off, that means we're going to have a horizontal asymptote. So we're going to have y equals 1 over 3. And that would be it for that one. Okay. Looking at this one, comparing the exponents on top with the exponents on bottom. My exponent on top is 3. My exponent on bottom is 4. So this is a case where we have something that is bigger on bottom. When it's bigger on bottom, our horizontal asymptote is 0. So this has a horizontal asymptote at y equals 0. Looking at the next one, I see that I have a degree of 2 on top. I have a degree of 1 on bottom, even though it's not written. So this tells me that this is bigger on top. So there is no horizontal asymptote. Okay, so there's no horizontal asymptote. But is my top exactly 1 degree bigger than my bottom? And yes, that is the case. So there can be a slant. So to figure out the slant asymptote, we have to perform long division. So I'm going to take 4x squared minus 3x plus 5. I'm going to divide x plus 2. So what do we need to multiply x by to get 4x squared? That would be a 4x. 4x times x, so let me write it out, would be a 4x times x is 4x squared. 4x times 2 is a positive 8x. We're going to draw the line, change all our signs. Then we see that we have 4x squared minus 4x squared. That cancels out. Negative 3x minus 8x is a negative 11x. We drop down the next term. Then we need to figure out what we need to multiply x by to get a negative 11x. And so that would be a negative 11. So we have negative 11 times x plus 2. That would be negative 11 times x, which is a negative 11x. A negative 11 times 2, which is a negative 22. Here we would draw our sign, draw a line, change all our signs. We see negative 11x plus 11x cancels out. We see 5 plus 22 is 27. This right here is our remainder. This is where our slant comes from. It comes from the quotient. So our slant asymptote is y equals 4x minus 11. And so that would be our answer. So we look at the next one. We see that we have a degree of 3 on top, a degree of 2 on bottom. So this is a case where, again, it's bigger on top. So there is no horizontal asymptote. My top degree is exactly 1 degree bigger than my bottom. So we can find our slant asymptote by performing long division. So we have x cubed minus 2x squared plus 4x minus 1 divided by x squared plus x plus 3. So what do we need to multiply x squared by to get x cubed? That would be an x. So we have x times x squared plus x plus 3. So x times x squared is x cubed. X times x is an x squared. X times 3 is a 3x. From here, draw the line, change all the signs. X cubed minus x cubed cancels. Negative 2x squared minus x squared is a negative 3x squared. 4x minus 3x is a negative or positive x. And then we drop down the negative 1. So what do we need to multiply x squared by to get a negative 3x squared? That would be a negative 3. So we have negative 3 times x squared plus x plus 3. Negative 3 times x squared is a negative 3x squared. Negative 3 times an x is a negative 3x. Negative 3 times 3 is a negative 9. From here, draw the line, change all the signs. And so right here, we see that negative 3x squared plus 3x squared is 0. 1x plus 3x is a 4x, and negative 1 plus 9 is a positive 8. This right here is my remainder. This right here tells me my slant. So my slant asymptote equation is y equals x minus 3. Okay. The last part of the review is doing our binomial expansion. So I see that I have an exponent of 6. So I do need to have Pascal's triangle. So I'm going to just do this down here. So I need to go until I have an exponent of 6, or I'm in the 6th row. So I have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. And then we get 1, 6, 15, 20, 15, 6, 1. So that is what we want for this one because our exponent is an exponent of 6. So I'm going to use those as my coefficients. 1, 6, 15, 20, 15, 6, and 1. The first term is an x. So I'm going to start with x to the 6th and work my way down. X to the 5th, x to the 4th, x to the 3rd, x to the 2nd, and x until I have no x. Then my second term is a positive 2. So that's going to start with nothing and then 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th, 2 to the 5th, all the way to 2 to the 6th. Then we just need to multiply it out. So 1 times x to the 6th is x to the 6th. 6 times 2 to the 1st, that's 12. X to the 5th. 15 times x to the, 15 times 2 squared, that's 15 times 4. 15 times 4 is 60. And then x to the 4th, the variable's kind of just tagging along. 2 to the 3rd is 8 times 20. That's a 160, x to the 3rd. 2 to the 4th is 16 times 15. That's 240, x squared. 2 to the 5th is, 32 times 6. That would be 192 x, and then 2 to the 6th is 64 times 1. Okay, so that would be x to the 6th plus 12x to the 5th plus 60x to the 4th plus 160x cubed plus 240x squared plus 192x plus 64. Okay, so that's a really long answer, but that would be it. When it comes to multiple choice, you just do enough until you get the answer or you can eliminate other answer choices. Okay, the next one, a binomial with the 4th power. So we already did Pascal's triangle. For this one, we're going to use 1, 4, 6, 4, 1. So I have 1, 4, 6, 4, 1. My first term is going to be an x, and I'm going to start with working my way down. So x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, no x. My second term is a negative 3. So we're going to go nothing, negative 3 to the 1st, negative 3 to the 2nd, negative 3 to the 3rd, negative 3 to the 4th. And so from here, we're going to multiply these out. So 1 times x to the 4th is x to the 4th. 4 times negative 3 is a negative 12. Times x cubed is a negative 12x cubed. Negative 3 squared is 9. 9 times 6 is 54. So we get 54x squared. Negative 3 to the 3rd is a negative 27. Negative 27 times 4 is a negative 108. And negative 4, or negative 3 to the fourth power is 81 times 1 is 81. So we get x to the fourth minus 12x cubed plus 54x squared minus 108x plus 81. Okay, looking at the very last one. Okay, again, we already have Pascal's triangle down here at the bottom. We're going to use the 1, 5, 10, 10, 5, 1 because my exponent is a 5. So I have 1, 5, 10, 10, 5, 1. I have my first term, which is a 2x this time. So 2x to the fifth, 2x to the fourth, 2x to the third, 2x to the second, 2x to the first, and then no 2x. My last term is a negative 3. So that's going to be no negative 3 to the first, negative 3 to the second, negative 3 to the third, and negative 3 to the fourth. And last but not least, negative 3 to the fifth. So you just multiply these out. So 2x to the fifth power, that's 2x times 2x times 2x times 2x times 2x. So 2 to the fifth power is 32. And then x to the fifth because we're multiplying by 1. 5 times 2 to the fourth times negative 3. Again, you could use a calculator for that, but that should be 240 x to the fourth. 10 times 2x to the third times negative 3, that would be 10 times 8x cubed times 9. And so 9 times 8 is 72 times 10. That should be 720 x to the third. 10 times 2 squared, 2x squared times negative 3, that would be 10 times 4 times negative 27. So it'd be a negative 1080 x squared. 5 times 2 times negative 3 to the fourth, that's going to be 810 x. And then negative 3 to the fifth power, that's going to be a negative 243. And so we get 32x to the fifth minus 240x to the fourth plus 720x cubed minus 1080x squared plus 810x and minus 243. Okay, so you would get that. So that's everything for the review. Hopefully this helps, and good luck on your test.